Today we're going to completely strip this beautiful MH28V, which in the United States is the Precision Matthews PM30MV. The reason I'm completely stripping this machine is because I'm going to convert this to a CNC milling machine. And I need to completely strip it because I'm not precisely sure of the exact length of the zero backlash screws that I need to purchase for it. So I'm going to start by taking the drive motor off, which is in this cowling, because that's a fair chunk of the weight of the head. So, I'm going to be taking this apart by myself, so I'm going to make things as light as I can. I think you can see that. It's at 1100 watts, which is a pretty powerful motor, but what's more interesting, it'll actually run at 6,500 RPM. That's very interesting, because I can belt that up to, near 1-to-1, or I'm going to lose a bit of torque. But for CNC milling, you want RPM. So what I'm going to do now is cut these ties, and I need to disconnect the motor and the wiring and the RPM pickup here, and I want to take this whole top plate off. Okay, now I shouldn't really have to say this, but I will. When dealing with any electrics, certainly mains power electrics, always have the plug to your machine unplugged. Take the damn plug out. Next thing, when you're dealing with wiring, as in this case, take a photograph of the colours of what goes with what. Also, you need to take note of the clearance here. Now I've measured that and it's 10 thou. Okay, be careful when you're feeding this cable through. This is or can be quite delicate. Okay, so there we go. Now to remove the head off this saddle, there's two main bolts up in here. They're just a shade over 3/4 of an inch. But the first thing you've got to do, there's a grub screw here. Now this locks the head from rotating, or one of the things that locks the head from rotating. There's a grub screw in here which goes in onto the casting. So we will slacken that off. You're not going to take it right out or anything like that, just slacken it off like that so it's just protruding out. Okay, let's take you under here so you can see what's underneath here. It's a bit dark, hopefully you can see that. This one is 17 mil, this one is 19 mil. If I can cut, that one in the middle is 19 mil. So this one needs to come completely off. Well, they both need to come completely off. But take this one, take the nut and the washer and that off this one first, and slacken that one and rotate the head round. And when you've got the head rotated round, it's easier to get that one out and hold it at the same time. Right, let's get this 19mm. Just put a hand underneath your electrical box, because when this slackens, it'll freely move around. Slack. Okay. Okay. So now we can easily manage it. I don't mind telling you, that's a fair lump. That is, I would say, easily 30 kilograms, which is what, 70 pounds, thereabouts. That was damn heavy, actually. Doesn't look it, but it's solid cast iron. Okay. Now the next bit. Okay, this next bit, I'm going to need to take these bellows off, but I also want to check to see how far forward this will come in relation to, well, the end of the base. Yeah, 35mm, which is 1.25 inches. I probably won't machine any of the base out. I don't think I need any extra travel than that. Okay, next thing I want to do is take this saddle off and this screw out. So I've got this locked up so it doesn't fall down when I got things undone. So I'm going to take this off first. And that's what's inside there. I know for definite that these two Allen bolts here connect to the screw. These two, I'm not so sure what they do at all. So we're going to undo these two and find out in a minute whether I've got to undo the other two. Make sure this is locked up, certainly when you undo these two, because this thing will just fall onto the base there. And I haven't taken the gib out yet, I've left the gib in there. Okay, these are a double lock nut, so you get a punch and one. Take those off. Okay, now we can undo the cap. Be careful, make sure these are locked up, the two locks, otherwise this will just drop. It will. Where did that go? Okay, that should just pop out from there. Okay, and that comes out. So you can see what's in there. This is what connects to the back of this, and it very tightly fits onto there, very well machined. So this is going to be crucial, because I'm going to have to make a new one of these to go with the ball screw that I'm going to put in here. So now I'm going to slacken the gib, because it's a bit tight on there for me to pull off. So, okay. So take the weight of it, unlock it. It should come off a bit easier now, with a bit of luck. Not going to, is it? You're not going to believe what I've just found inside here, because they have fitted a gas strut on this. So that's what these two screws are here. When I get this off, I'll show you down inside there. Okay, come on, Gib. Okay. There's two little brass pins as well. So I think you just saw drop out. All right. Okay. For the moment, I'm going to leave this in here. I want to take the saddle off because I want to leave this in here for measuring purposes. So I'm just going to take the gib out of this. Come on. Okay. Okay, this gas strut is connected at the bottom down there. The only way of getting at it is from underneath. So, we can do this without flipping the trolley over. Okay. Oh, this is a fairly heavy thing. Oh, God. Ugh. That's heavy. So here we go with a probably £100 lift. You might like to use a friend for this. I'll lift it with a friend. I might be 70, I still got what it takes. I'll just swing you around here, just have a look at that. That is the stand, or the bare bones of a stand that I've put together to assemble the mill on. Now the standard base that would come with that machine is quite a bit narrower than this. It's about that wide. I needed something much greater, so these are the measurements that I came up with, and indeed I'm going to extend at an angle to about here on each side, and then make a top cabinet for it, and also waterproof it. But like I say, this is the bare bones. Now then, let's swing you back round so you can have a look at this. Okay, I hope I'm not too overexposed. I've got floodlights over there facing this way, and I've had to open up the big roller door so far because it's getting so hot in here, and well, I had to do something. Okay, so there's some of the parts, the total sum of the parts, and that's how to strip it down. It's probably not totally necessary to take the column off. But I took it off because you know, it's easier for me to, you know, measure up for the Y-axis screw and what have you. But it could have been done, you know, once you know the measurements of everything, I suppose. With the column on quite successfully, really no need to take it off. The only thing that's going to be altered is the cap. And looking at this, and indeed this is cast iron too, and the way it's made, I am overexposed. I think I can use this again. I think I can use this in the conversion to CNC. There's plenty of meat on it for me to, you know, make an extension housing for a NEMA 34. Absolutely no problem on that. Beautiful machine. It's beautifully machined. I think I can use that again. We'll see. Nothing has to be touched with the head yet. We're going to leave that for a later video, much later, maybe 6-9 months from now. And looking at the original motor, I see no problem in, depending on the torque of it, I should think it'd be fairly torquey. I think I can use that motor and belt it up maybe 1-to-1, which will give me, what, 6,000 RPM? I forgot what's on the motor now. Oh dear. 5,500 RPM. So I should be able to make a pulley system with 1-to-1 ratio and 2-to-1 ratio, which would give me then take it back down to 2,700 thereabouts for doing face milling, and then 5.5 for, you know, doing ordinary mill cuts. Basically 90% of my machining is aluminium. I've really got no call for you know, steel. Cast iron, yeah, cast iron, okay. But you know, this will machine anything. Titanium, if you put it under it, it'll do it. Oh, another thing too, to keep in mind, don't mix the Z and the X gib up. They're the same length, because they're hand ground, scraped rather. I don't know, they're an absolutely lovely fit. So if you put the wrong gib in, the wrong axes, it's either going to be too tight or it's going to be too sloppy. Okay? They're matched. So keep that in mind. But I'll mention that again further down the road. So I have to now work out exactly what screws, the length of screws. I'm probably not going to be able to get the exact length screws I want. The Y and the wherever it is, this one, the Y and the Z, no problem at all. If I need be, I can order a meter and then cut off what I want. It's the X is a bit of a problem child. Judging what I'm seeing, this is really high grade machine. I mean, no wonder it was designed by the Germans. It's beautiful. You'd swear it was built in Germany. The castings are beautiful. Everything is perfect with it, actually. Okay, so there it is, stripped. Oh yes, what I was saying. So, yeah, the problem child is the X, because it's got to be machined both ends. You know, the bearings, or the thrust bearing, and the motor, you can actually put the motor on either end, doesn't really matter. Whether you know, you're only catching hold of the last ½ inch with a coupling, and you've got that on both ends. If you want to support the other end, you know, it has to be pretty well exactly within a millimeter. They do call it a floating end, okay, but it doesn't float. Okay, so there you have it. One stripped medium to large, very nice milling machine, which will over the next couple of months be a fully operational CNC mill. Okay, so I hope you've liked the video today. Hope you've been entertained, and please press like, subscribe, and if you really like what I'm doing, you may like to support the channel by becoming a patron to the channel, because it's the patrons behind the channel that allow me to do things like this and make videos for you guys to show you, well, what I consider the best way of doing a particular job, mainly converting to CNC, because a lot of the people, professional people that I've seen out there that are selling kits, they don't, should I say, show you enough. They show you bits and pieces. Oh, this is me putting my kit together, and they only show you half the job. They don't show you exactly what you have to go through. So that's what I intend, or have intended, to do with all of my videos. So a complete novice can pick up some Allen keys, screwdrivers and spanners, and actually have some idea of what they're doing. At least that's my aim. So, thank you for being there, and I hope you come back and see some of my other videos and continue watching this series with this Optimum MH28V, which is also in the States, is the Precision Matthews 30MV. I think that's the right prefix on it. The only difference between the Australian version, or should I say the Optimum version, and the Precision Matthews is this has a 2-speed head. and the Precision Matthews already is belt drive. This is gear driven, which is fine. Okay then, so we'll call this one done. So thank you for being there, thank you for watching, and it's bye for now.